Okay, P3. Before we begin P3 on dividing functions, there's something that I need to reiterate for you guys. I've never told you this, but hopefully somebody before me has told you this, but they may have not explained it exactly this way. So, I have a question, and it is, what if I gave you that? Okay, hopefully all of you would say, hey, it's 3. Okay, because most of you would say 6 over 2, or 6 divided by 2 is 3. Well, just for today, let me ask it this way. What can you multiply 2 by to get 6? What can you multiply the bottom by to get 6? And again, the answer is 3, right? Because 2 times 3 is 6. Well, what if you have this? What do you multiply the bottom by to get the top? What do you multiply 2 by to get 0? 2 times what is 0? Well, 0, right? Okay. And then what about this? Same question. What can you multiply the bottom by to get the top? What can you multiply 0 by to get 2? 0 times what is 2? Think about it. It's not 2 because 0 times 2 is 0. It's nothing. You can't. 0 times anything is never going to give you 2 or 5 or 10. Okay? So when 0 is on bottom, it is undefined. When 0 is on bottom, undefined. When 0 is on bottom, undefined. When 0 is on top, then 0 is what you got. If 0 is on bottom, undefined. And what undefined means is there's no rule for it. It can't be done. There's no way of getting an answer. So anytime you have 0 on bottom, it's undefined. Now, the reason that I'm going over that is for what we are doing today. Let's squeeze that in so we can see everything. Okay, so this is pronounced f over g of x, or f divided by g of x. Here's your f, here's your g, here's your f, here's your g. So if I put this on top of this, right, then I have a fraction. And I have a fraction that has x's on bottom. And sometimes there's an x, there's an existing x that would make the bottom 0, and you can't have the bottom to be 0, so we can't allow us to say that we can let x be that number. So what we're going to do, whatever the bottom is, we're going to write it down, and we're going to say it cannot equal 0. Well, what we're going to do is get x by itself, and we're going to do it the way we normally would if that was a equal sign instead of a not equal sign. So we're going to subtract 6. So 5x cannot equal negative 6. We're going to divide by 5. We're going to divide by 5. And what does this right here say? X cannot equal negative 6 over 5. X can be any number except negative 6 over 5. And that's what the domain is. The domain is the x, the domain is left and right. So the domain is any number in the whole wide universe except for negative 6 over 5, because negative 6 over 5 makes the bottom 0, and the bottom cannot be 0. Next, what is the domain? So we put, not that. Just a second. It's acting up on me again. And off and scroll. And draw. Okay. So we're going to put 4x over negative 5x plus 6. What is the domain? Anytime it's asking for the domain, we're looking at the bottom. So we're going to say negative 5x plus 6 cannot equal 0. We're going to take that 6 over. We're going to bring the negative 5x down, cannot equal a negative 6. We're going to divide by negative 5. A negative 6 over a negative 5 is a positive, so x cannot equal positive 6 over 5. What is the domain? Any number except for 6 over 5. And it just kind of keeps on going like that. So we are going to talk about the domain. So 3x plus 2, negative x. Negative x cannot equal 0. Divide by negative 1. X cannot equal negative 1. Or, I'm sorry, that is not right. 0. Because 0 is on top. 0 is on top, then 0 is what you got. So it can be any number except for 0, because if you put 0 on bottom, then you have 0 on bottom. 2x minus 2 over x squared plus 9x. Okay, this is when unit J comes back into play, and K. So we cannot allow the bottom to equal 0. So if I take an x out, I'm left with x times x plus 9 cannot equal 0. So x cannot equal 0 because that makes this 0. And x cannot equal negative 9 because negative 9 makes this 0. So x can be any number in the whole wide world except for negative 9 and 0, because negative 9 and 0 makes the bottom 0. So same old, same old. So negative 3x squared plus 10x minus 3 cannot equal 0. Hopefully this looks familiar, because we're going to have to factor it. Move the negative 3 over, get positive 9. What multiplies to get 9 adds to get 10. 9 and 1. Then we put the negative 3 back into play. So right now it's x minus 3 and x minus 1/3 cannot equal 0. So your zeros are 3 and 1/3. They cannot equal because of that right there. So x can be any number except for 1/3 and 3. Alright, now we're going to be doing some work. Twice as much work. So what is f divided by g of x? So we're going to put negative 3x squared plus 3 over negative 2x. And then, there we go. What you're going to do, it's pretty much done for the most part. The key on this is to figure out if anything is reducible, and basically think of your factoring skills. I could take a 3 out of the top, but the 3 on top with the 2 on bottom is not going to do any good because 3 over 2 does not reduce. So for most of these, if you just put the f over the g, you're going to be finished for this part, and that's what you're going to be putting into the box. But then we have to figure out the domain because we have x on bottom. So we take the bottom, we say cannot equal 0, we divide by the negative 2, and if 0 is on top, then 0 is what you got. So see this x equals right here? So you're going to put a 0 in there. You cannot put 0 in the problem because you would not get an answer. Okay, same. So 2x squared minus 3x over negative 5x plus 2. I could take an x off out of the top, but I couldn't take an x out of the bottom. So it's not really factorable. It's not, you're not going to be doing anything to be able to do that. So that's going to go into this box. And then we have to find the domain. So we take the bottom, set it not equal to 0, move the 2, bring the negative 5 down, divide by -5. A negative over a negative is a positive, so x cannot equal a positive 2/5. So 2 over 5 is going to go in that box. Okay. Now this is when, for the ones that want to make sure they're getting it right, you could do something, or, you know, just kind of fumble and see if it works out. So what we're going to do, because honestly, I don't know if it works or not. So that's why we're going to do some extra work to see if anything happens. I do not know. So what we're going to do, this is an answer, but I don't know if it's a simplified answer because I don't know if anything reduces out. So what we're going to do, we're going to factor the top. So I'm going to move the 2 over. So I'd get x squared plus 6x plus 8 x plus 2 times x plus 4, because 2 times 4 is 8 and 2 plus 4 is 6. Divide by 2, divide by 2. Let me back up. Let me way back up. Well, sometimes I don't see it because I don't look for it, and I keep telling you that's the first thing that you're supposed to ask yourself. And sometimes I don't ask myself. You should have taken a 2 out. That's what we should have done. Plus 3 plus 2. Okay, and when we do that, this will be x plus 1 and x plus 2, because 1 times 2 is 3 and 1 plus 2, 1 times 2 is 2 and 1 plus 2 is 3. So the top is factored. On the bottom, we can take out a negative 3x because 3 goes into 6 and 3, and there's an x and everything. So if I divide by negative 3x, I'm left with an x plus 2. Oh, good. I'm glad I didn't waste my time. Okay. Now, for your answer, in the first box, it is going to be this. Okay? I'll explain that better in just a second. We have to find the domain before I explain what's going on because I don't want to cancel things out and confuse you anymore. Let's find the domain. So what would make your bottom 0? X cannot equal 0, and x cannot equal negative 2, because negative 2 plus 2 makes it 0. So 0 and negative 2 go in those boxes. Now, what happened? I had an x plus 2 on top and an x plus 2 on bottom. Anytime you have something on top and something on bottom, you can cancel them out. But I had to find the domain first before I could do that. All right, any questions, let me know.